Most people have a qualitative idea of what an outlier is, but in statistics there is a quantitative definition of what an outlier is, and statisticians use the 1.5 times the IQR criterion. IQR stands for interquartile range. So let's take the same data set that we used to talk about the box and whisker plot. The range is the maximum minus the minimum. The interquartile range is Q3 minus Q1. So in this case, the IQR, the interquartile range, is 7, 84 minus 77. So 1.5 times the interquartile range is just 1.5 times 7, which is 10.5. So if you add that to Q3 plus 1.5 times IQR, you get 94.5, and that's the upper cutoff. So all numbers above 94.5 are outliers. So in this case, 97 and 100 are outliers. So on the lower end, you take Q1 minus 1.5 times IQR, that's 66.5, so all numbers below 66.5 are outliers. Since the lowest number is 70, there are no lower outliers. This can make more sense when you think about this in a graphical way. That distance marked by that arrow is 1 times IQR. So now this slightly longer distance is 1.5 times IQR. So let's slide that up. So the left end of that starts at Q3, and then you can see that the graphical representation of Q3 plus 1.5 times IQR. So that's why 94 is the upper cutoff, and 97 and 100 are upper outliers. Typically, software will have the whisker stop at the largest number that is not an outlier. So you can see that 92 is not an outlier, and that's why the upper whisker stops at 92. And then outliers are represented by dots. So let's do the same thing at the lower end. Move the length 1.5 times IQR that starts at Q1 and moves to the left, and you can see here that there are no lower outliers. So the conclusion is there are upper outliers of 97 and 100 and no lower outliers. And all the work that's shown down here, all of that is work that statisticians show in order to demonstrate what is an outlier and what's not. And that gives you an idea about the quantitative way of finding outliers in statistics using the 1.5 times IQR criterion.